Hello! Welcome to my vlog of introducing the periodic table. First thing you're going to need to know is the atomic number. So the atomic number on the periodic table is the number that is categorized in the order. It is also how many protons and electrons are inside that element. And then we have the average atomic mass, which basically is how much the element weighs. Now, if you were to subtract that number from the atomic number, you would get the amount of how many neutrons are in the element. So there are three things in an element: neutron, electron, and proton. Electron is positive, proton is negative, and neutron is neutral. Next thing you're going to need to know is the element symbol. It'll either be 2 letters or 1 letter. If it's 2 letters, it has to be a capital and then a lowercase. If it's 1 letter, it has to be just capital. The atomic symbol is used as an abbreviation for the symbol. I know some of the symbols don't make sense, like iron is Fe, sodium is Na, lead is Pb. Well, it's because it's based off the Latin word for the element. Then we have groups and periods. It's basically an organization for the elements. Groups are up and down, and periods are side to side. You can remember this because periods, when you write, you end with a period. When you write, you go side to side. And up and down is a group, because it's not a period. Next thing you need to know is metals, nonmetals, and metalloids. Now, I'm pretty sure most of you know what metals are. Metalloids, I know what you're thinking, it's not a metal robot. A metalloid is what separates a metal and a nonmetal. A metal is something that can bend, can conduct electricity, temperature. Non-metal cannot. Next, we have liquids, gases, and solids. Obviously, I'm a solid because I'm not going anywhere. Gases, they're everywhere. We can't see them because they're so small. They're not fixed in a position to the point where we can see them. See, my arm is filled with a bunch of molecules that are condensed together to make a solid. Liquids, they are all mostly near each other, but they move in a more free way. So, they move in a more freely direction. Solids, fixed position. Liquids, not as much. Gases, do whatever the heck they want. They just go anywhere, man. They're rebels. Next, we have special regions. This periodic table for special regions. Each color is its own region. It basically defines the qualities of this element. Each one has something special about it. It mostly depends. Hydrogen is its own metal. You know, like H2O, H is hydrogen, and O is oxygen. H2O is water. H2O is a mix between oxygen and 2 hydrogens. H2 means there's 2 hydrogens. You don't put H2O1, because it's basically like saying O times 1. It's just going to be the same thing. You don't do that. And now, you're probably wondering, how do you mix the two? Well, that's where valence electrons come in. So valence electrons are what you use in the periodic table to determine how many times an element can connect with other elements. There is a bunch of different elements, and depending on which column, this big gap in the middle really is considered 1, and then you count from the rest. So there should be a total of 8. If I were to use H2O, O has 6 valence electrons, so it would be able to connect with 6 different elements. Hydrogen has 1 valence electron, so it would be able to connect with only 1, not 2, but count them 1 other element. If we were to do H plus O plus H, 2 H's and 1 O, therefore you get H2O. That is valence electrons. Now, if you take away a valence electron, it could make the element very unstable. It's like taking away candy from a baby. They freaking scream like crazy. You do not want that to happen. It's a no-no. Alright? Just no. So that is the periodic table, kids. And if you have any more questions, just contact me at this number. I'm going to put that at the bottom later. Thank you for watching, and have a nice day.